Okay, so lesson 1.1, solving equations. A mathematical sentence containing one or more variables is called an open sentence. A mathematical sentence stating that two mathematical expressions are equal is called an equation. Notice the same roots. So if we see an equal sign, we know we have an equation. If there's no equal sign, then it's just an open sentence. In an equation, if the variables cancel out, then there is no solution. And we use this symbol for the empty set, a zero with a line slashed through it. Now sometimes you may have to distribute and combine like terms first. So now we're going to step back to basic algebra problem. We first locate our variable. If you want to circle it, that's fine. We look at what's happening to it. It's being multiplied by 5 and decreased by 3. So we have to work backwards through the problem and do everything opposite. So since it was being subtracted by 3, now we add 3. Which is going to give me 5x equals 25. Now, since the x is being multiplied by 5, we're going to do the opposite, which is divide, which gives me x equals 5. And here's the beauty of algebra, that you can get an answer and know whether you're correct before you even move on to the next problem, by just taking this answer and plugging it back in. So 5 times 5 is 25, minus 3 is 22. We can move on. Now, over here, number 2, we have a lot going on. We have a bunch of y's, and we have numbers. So I'm going to combine like terms first. 7y's take away 3y's is 4y's, plus 2 more y's makes 6y's. Minus 4 equals 26. Now, again, I'm trying to solve for y. So I'm going to work my way backwards and add 4 to both sides, which gives me 6y's is equal to 30. But I don't want 6y's. I only want 1y. So I undo the multiplication by division and get y equals 5. Again, I can take that same answer and plug it back into my original equation. Here, here, and here, then I should get the same answer. If I did, I'd get 7 times 5 is 35, minus 5 times 3, which is 15, minus 4, plus 2 times 5, which is 10. And that should equal 26. 35 minus 15 is 20, minus 4 is 16, plus 10 is 26. We are correct. Okay, so now number 3, we have these numbers on the outside of the parentheses to distribute. Note, this is a negative 3. So we're going to send the 5 in to both numbers, and we stop there. We only distribute to what's inside the parentheses. That's going to give me negative 10x plus 10. Notice, positive times negative is negative. Positive times a positive is positive. Now I'm going to send the negative 3 in and get negative 3x and positive 15, because negative 3 times negative 5 is positive 15, equal to negative 20x minus 6. I'm going to combine like terms. Notice I use symbols to distinguish what I'm combining. So that's going to give me negative 13x plus 25. Equals negative 20x minus 6. Now I have to just determine where do I want my x's. Most people move their x's to the left side and their numbers on the right. It doesn't make any difference. You can move the negative 20x over to the left. You can move the negative 13x over to the right. Either way, you'll get the same answer. I am going to move over to the left because I'm looking ahead. It's kind of like playing chess. You think ahead a few moves. If I add 20x's to both sides, I'm going to end up with a positive x, and that's going to save me a step later on. If I would have added 13x to both sides, over here I would have ended up with a negative 7, which then I'd have to still get rid of the negative. Now I'm still going to have the step of getting rid of a whole number. I just am saving myself the negative. It really makes no difference. It's about the same amount of work most of the time. So 20x's minus 13x's is 7x's. Plus 25 equals negative 6. I need to work backwards. Subtract the 25. And that gives me 7x equals negative 31. If I borrow $6 from someone, I borrow $25, I owe $31. Now I'm going to divide by 7, which gives me an answer of x equals negative 31 over 7. Now notice our direction says round to the nearest hundredth when necessary. So that means we want a decimal answer on this problem. Otherwise, without that instruction, we could leave it as negative 31 sevenths. We could also write it as negative 4. 7 goes into 31 4 times. It's 28. With how many left over? 29, 30, 31. 3 sevenths. That would also be an appropriate answer, which is going to also lead us to where our decimal is going to be. It should be negative 4 point something. So 31 divided by 7 is going to be negative 4.4, and remember it said round to the nearest hundredth. So I look at my calculator and I get 4.428. Well, the nearest hundredth spot is right here. I'm going to look at the 8. I'm going to look at the 8 and round up and get x is equal to negative 4.43. There's my answer. Moving up. Okay, a little bit of work to do here. Okay, so this time I have fractions to multiply and send in, which is not that big of a deal. We're going to take a half of everything, a negative half. So half of 4 is 2, and negative times a positive is negative. Half of 6 is 3, and negative times negative is positive. So that simply ends up being negative 2x plus 3. Now in this case, I'm going to multiply by the 2 and divide by the 3 on each of these numbers. So when I send this in, I get 2 times 3, which is 6, divide by 3, and I end up with 2 again. Another way of looking at that is the 3's cancel. And some of you may do it that way. Either way is fine. Same thing here. I can take 2 times 12, which is 24, divide by 3, which is 8. Or I could have canceled the 3 with the 12, which is 4, times 2 is 8. Either way, I end up with the same answer. Now I'm going to combine my like terms, and I end up with 2x minus 2x, which is 0x. 3 plus 8 is 11, equal to 21. But when I subtract 11 from both sides, I end up with no x's equals 10. We cannot have an answer of 0 x's. Our x's basically drop out, so we have 0 x's, which is 0, and this is saying that 0 is equal to 10, which is a false statement. So our answer is no solution, or you can put the empty set. Okay, to get rid of fractions, you can multiply each term by the least common denominator. So basically what I want to do here is, I want to get rid of this 3. So what I'm going to do is multiply this by 3. But I can't just multiply and change one side. So I need to multiply both sides by 3. When I do that, the 3's cancel there, leaving me with the 2x minus 4. Over here, I get a negative times a positive, which is negative, and 5 times 3, which is 15. Now I'm back to a basic algebra problem. I'm getting the x by itself by addition, which leaves me with 2x's equal to negative 11. Divide by 2, x equals negative 11 halves, or negative 5.5, or negative 5.5. Any one of those answers is appropriate. Now over here, number 6, we got a little bit more work to do because we have a 7 on one fraction in the denominator and a 3 in the other. So I need to think about what numbers the 7 and 3 both go into when they're multiplied. So 3, 6, 9, 12, 15, 18, 21. So that sounds familiar. 7, 14, 21. There's my common denominator. So I'm going to multiply each of these things by 21. Also known as 21. Now, I'm just going to cancel. This 3 goes into the 21 7 times, which then I multiply by 2x and get 14x's. This 7 will cancel with the 21 3 times. Times 5 is 15, equal to 210. Now remember, that's one way of thinking about it. If you want to work with bigger numbers, you could have taken 21 times 2, which is 42, and divide by 3, which is 14. And you could have taken 5 times 21, which is 105, divide that by 7, and you would have gotten 15. So either way, you're going to end up with the same answer. Now I'm going to subtract 15 from both sides. That leaves me with 14x's equal to 195. Then I'm going to take and undo the multiplication by dividing by 14. And I get x equal to 13.928. I'm going to follow the previous rules of the directions, which said round the nearest hundredth. I look at the 8, which tells me to round up. And there you go.